Hello everyone, welcome back. Today we'll be learning how to create tables and we want to look at the session objectives of this particular session. Now we are going to look at the SQL Server data types. Now this is something we learned in session 5, so I'll refer you to that particular presentation. Please go back, watch that video to understand more on the SQL Server data types. We'll also be in a position to understand how to create, how to change, and how to delete or drop tables in SQL Server. We'll be in a position to describe the procedure to add, modify, and drop columns in a table. Let's get started. Introduction. Now, one of the most important types of database objects in SQL Server is the table. And tables in SQL Server contain data in the form of rows and columns. And each column we have data of a specific type and size. Very quickly, we look at the data types overview. Data type is an attribute that specifies the type of data that an object can hold, such as numeric data, character data, monetary data, and so on. And the data type also specifies the storage capacity of an object, as we saw in session 5. Once a column has been defined to store data belonging to a particular data type of another type cannot be stored to it. What you're simply saying is that if I define a certain column that I'm going to store school fees, it's actually going to accept monetary values. I cannot add the date inside that particular column. It's not going to allow that. And hence, as you can see down here, this enforces data integrity. Now, if an attempt is made to enter a character data into an integer column, this will not. This basically talks about the different kinds of data types. As mentioned when we started, please refer to the video for session 5. Now, let's look at what we're supposed to do in this session, how to create tables. Now, the create table statement is used to create tables in SQL Server, and the syntax to create a table is given below. We type in create table, then you can specify the database name, then the schema, then the table, and then after that you tell us the columns which are going to be in that particular table and the data type of each of those columns, and you finally tell us whether it's going to be null or not null. Null or not null basically means that we are allowing you to store empty values, that is, you can leave the column without entering any data in that particular field. Where database name is the database where we want to store that particular table. Table name is basically the name of the table we want to create, and you can see it can be a maximum of 128 characters. Column name is the column in the table, and this can also be 128 columns. We have columns. So what we are saying is that there are some columns which allow you to leave them without entering the column name. Now, as you can see here, we are saying that column names are not specified for columns that are created with a timestamp data type, and the default column name of a timestamp column is timestamp, and this simply means that timestamp is you telling us the time a particular transaction occurred. Like when you paid for goods in a supermarket, if you look at that receipt, you'll see it contains when you did the shopping. If you look at the ATM receipt, you'll see it also contains the time that you did the transaction in the ATM. Then finally, you have the data type. Data type basically is telling us the type of data that we want to store in that particular column. We have an example here. The following code snippet demonstrates creation of a table named DBO customer 1. We have the syntax create table. DBO, remember we said DBO is database owner. Then the name of the table is customer 1. The customer ID field is going to store numeric value 10 decimal. It's going to allow 10 numerals and 0 decimal places. And this one does not allow you to leave it empty. You must specify a value. You can see we are saying not null. Customer name is going to be varchar. Now, we're not going to use varchar so much because if you read the Microsoft documentation for this, this does not support Unicode characters. So we'll be using the one which supports Unicode character set, that is N varchar. They basically do the same, and it's just that one supports Unicode and the other does not. This is going to store a maximum of 50 characters, and it does not allow you to leave it blank, and this is going to be created on the primary file group. Now we want to switch to the machine where we are going to execute this command. So like we did in the previous session, kindly highlight this and copy. Now, let me switch over to the machine. One moment. You can see I've opened SQL Server Management Studio, and we want to open the solution we are working with in the previous session. We click on File, go to the second from last option, Recent Project and Solution. You do this if you already have an existing solution. If you are just working on a single file, then this option would be much better. We click on our solution. It opens, and it opens the last script we worked with, that is the one for session 6. Today we are going to create a new session for session 7, creating tables. That's what we're going to call it. I'll switch over to the Solution Explorer. Then in the Queries tab, if this is collapsed, basically you can expand it or scroll down. Right click on Query, select New Query. It creates for you a new query. Then, as we did in the previous session, you right click on this, select Rename, then you call it Set7 Create Tables. Set7, tap on Enter. Now, as usual, if you look at what we did here, we start by explaining what it is that we are doing in this particular session. I'll type in the comment of what it is that we want to do. I can close this, we're not working with it anymore. Let me type in that very quick. All done. I've typed in the comment of what it is that we're learning here. Then now I can come in here and paste the command that we want to execute. Now, this is going to create that table as you have seen in your slides. And remember to add a comment on what it is that you want to do. And if you execute this command right now, it's not going to work. Please tell me why this command is not going to work. There's something you're supposed to do first, then your command is going to work. Now, please pause the video and find out why this command is not going to work at this particular juncture. Then fix it, and let's continue. Now, I hope you've been able to figure out why the command is not going to work. It's because we are directing this command to the master database. We need to specify the database we want to use. You can click on this drop-down arrow here and specify the database which you want to use. You can either use this one we created, the customer, or you can use the sales. It's your preference. Now I'm going to use the customer one. Then I'll click that. So that selects the database which I'm going to direct the command. Then after that, I can execute the command. I'll save this. Remember, we said it's important to always save your work. Highlight. You can execute 2 commands at once. Click on execute. You notice that the first thing the SQL Server did was to switch the database. After switching the database, it created this table. To verify whether this table has been created, we are going to go to the Object Explorer. You notice today I don't have the Object Explorer, and remember we said to display something which is not here, you go to the View menu and select it from this list. The keyboard shortcut, remember we said, is F8. Then I'll click on the Connect button, click on Connect, and if I go to Databases and come to Cast, expand the Tables node, you can see that the customer database is actually created. Now currently this table doesn't contain any data. We continue. We want to make changes to this table that we created. To do this, we use the alter table statement, and it is used to modify a table definition by modifying or changing, adding, dropping columns and constraints, reassigning partitions, disabling or enabling constraints and triggers. We will see this later. Now, the syntax for the alter table statement is given below. Alter table, then you give us the database, then the schema name, then the schema name dot table name. Alter column, you tell us which columns you want to change, and you can change their data type and also specify whether they are going to be null or not null. You can also go ahead and add columns to a table. Like let's say if it's a student's table, you only had their names, you had their phone number, and you want to add their email, you can add that particular column. Or you may also want to remove some columns. Let's say you had added the fee column in the student's table that is supposed to be in the payments table. You can also do that. Now, alter column basically, as you can see here, specifies that a particular column is to be changed or modified. Add, this is when you're adding one or more columns. Dropping means you are deleting columns from that particular table. Now, we want to modify this table, and we want to modify the customer ID and increase its size from, if you look at your query, the original was 10, and now we want to increase that to 12. And the following code snippet shows how to add the contact number column to this particular table. Now we're going to highlight this. Let's switch over to the machine. Now I'm executing this on the laptop, or you can do this in your own machine. So I've logged in now as the current user. I'm not using the SA, I'm using Windows Authentication. And I hope you did the assignment I told you in the previous session. I'll expand the databases node. You can see we have the customer database. And currently, if you look at this table and expand the tables, the columns node, you can see it only has 2 columns. That is the column ID. Then you can see the current is that it has 10, and this one is 50. This is what we want to modify. Then after executing the second command, we should have the third column. That is the contact number. I'll highlight both of them and execute them. Click on execute. Okay, the command completed successfully. Let's see what changes were made. The first thing you need to do is to refresh the database. Then expand your databases, come to tables, nodes, DBO, columns. You notice now right off the top that the table has 3 columns instead of 2. Then you notice now instead of 10, we now have what? We have 12. That is how you make changes to a database table. If you want to remove an existing column, you use the drop column statement as illustrated in your slide. Let us go back there. I'll save this first. Then let's go back to the slide. Now, this is how we drop the contact number column. So you specify the database you want to use, the alter table statement, then you specify the you specify the drop column statement. Now, under certain conditions, columns cannot be dropped, such as if they are used in a check, foreign key, unique, or primary key constraint associated with a default definition, and so forth. We've not yet covered some of these. Just bear with us for now, but we'll cover them later, and you'll understand why this is not allowed. Dropping columns which are associated with another column in another table. We copy these statements and paste in our script and execute it. Purpose of the statement, then we execute it. Click on execute, and it does that. Let's go back to the Object Explorer. We refresh, go to the databases node, tables, then you can see now we have our 2 columns. The third one has been deleted or dropped. Kindly be careful with that command. Now, the next is a very destructive command, that is the drop tables. It's almost as destructive as the one we looked at yesterday, dropping databases. Now, database, of course, is more destructive since it contains the entire collection of tables, views, triggers, and everything else. Now, the drop table statement removes a table definition. its data and all associated objects such as its indexes, triggers, constraints, and permissions specification for that particular table. Now, the syntax for drop table statement is given below. So drop table, then you specify the name of the table you want to delete. And we have a statement illustrating this. Please, let's copy this, then paste and execute. We have this, and word of caution, be very careful with this statement. I'll highlight this, click on execute. Go back to the Object Explorer. I can pin this down. You can still see this, so I'll just refresh this, come here, go back to. Then once I come here, you notice that the table is actually gone. Please be careful with that. Now, question. What about if you just want to remove the data but preserve the associated permissions and constraints with that particular table? There's another statement. I'm just going to give you a note here. Make sure you read more on this. There's this statement called the truncate table command. Now what this does is that it removes all the data in the table but does not delete the table structure. Everything remains the same. It's like moving a house. You leave the rooms intact, but you remove everything within that particular building or house. So this is a better preference, or this is less destructive as compared to the drop table command. Because even if you were to recreate this, you'd have to remember all the permissions that were set and do that from scratch. We move on. Data modification statements. Now, statements used in modifying data are the insert, update, and delete statements, and these are explained below. Insert statement. The work of the insert statement is to add a new row or tuple in an existing table. The syntax is given down there. Insert into, you specify the table, then you specify the values which you want to insert. Table name is the name of the table we want to insert data into. The into statement is an optional keyword used between the insert statement and the target table. Values is now the actual details you want to insert in that particular table. We have this example. Use that. Then now we'll have to create this table very quickly. Then now we can insert the details. Let's do this. Now here we can see we have this code snippet that tells us how to add a new row to the table 2. You are not given the statement to create that. Now I want you to look at this and see if you are able to pick up the values here and then create them based on what it is that you have learned in session 5 and the 6 slides that we saw earlier on in the data types. Do that very quickly. Then after that, we're going to copy this statement to insert these values or to add these values into that particular table that you create. You don't have to call it table 2. You can call it customer. You can call it buddies. It's basically up to you to decide what it is that you want to call the table. You can see what I've done here on the laptop. I've created the buddies table with these details. And on your campus machine, you can see I've called it customers. I was just saying it's basically up to your discretion. I'll click on the execute, and you can see the command completed successfully. The command completed successfully. Then I'll also execute on the laptop, and you can see that the command completed successfully. Now we want to add the details of Richard. We go back to the slides. So these are the details we want to insert. If you've given it either customers or buddies, you'll have to change this name of table 2 to either buddies or customers. So please copy this statement and then execute it. All done. Now I want to add a record into the buddies table in my machine. Then we're going to add the one for the customers table in the campus machine. We highlight, then we click on execute. One row affected. Then we come here do the same. The campus machine, execute, and you can see that, you can see that one row was affected. Now, if you want to see these details, please expand the tables node. You have to refresh first. Databases, then go to the customer DB, go to tables, then check the table that you created. If you're using the customer table, make sure you do that. You right click on this table, then you select top 1000 rows, and you can see the details for Richard are given here. Now this opens for you another query window. You can close it, you don't have to save this, and this was just for demonstration purposes. Remember to save your work. Let's move on. Now, if you want to make modifications to the data in the table, you use the update statement. And its work is to modify data in the table, and the syntax for the update statement is given below. You write update, you specify the table you wish to modify, then you use the keyword set. Set basically is used to change the data that is already in that particular column to something else. And we have an optional where clause. And the work of the where clause is to search what it is that you want to change. Now, we have this example. What we want to do is to set Richie's contact number to. Now, we can see the example we are given in your slides. We are told to change the contact number for Richie. And remember that this table we created did not have the contact number. If you look a few lines up in your query window, you notice we had the statement to add the contact number. Please copy that, use the alter statement to add that column into either the customer or buddies, whichever you created. Then after that, highlight this statement, paste, then we can take it from there. I've made the changes. I'm not going to show you how to do that. Please, I told you to refer to the previous command we issued up. Now, we write the purpose, update Richie's records by adding his contact number. We are going to update the customer's table and set the contact number to this value here, where the customer ID equals to 11. Highlight this, then click on the execute command, and it tells you one row affected. There is also another way of doing this. I'll just paste it inside your command window so that you can see, and then you can read more on this. You can also issue this command to achieve the same purpose as this, and it's just a matter of choice. This is easier to use because most likely we don't have customers with duplicate numbers. Of course, you can always have several people called Richie. So please just note that. We continue. Delete statement. Now the delete statement removes a row from a table, and the syntax for the statement is given here. You delete from, you specify the name of the table, then you give us a search condition of what it is that you want to delete. Now, the example which is given here is we are going to delete Richie's records. You remember this is where we have just set his number to this. Highlight this, then switch to your machine, and let's take it from there. Now, I've added this command and we want to execute it. To do this, we just highlight and then click on execute. Remember, you can also use F5 to execute this particular command, and that is done. Now, these delete changes are very destructive, as I said, and remember we said once you delete a record, it's gone permanently. Now, what we want to do, so let me type in what I want you to do here. Now, your assignment or challenge is given here in line 30. We add 5 more customers or buddy to your table for practice. We move on. Column nullability. Now, the nullability feature of a column, as I discussed earlier, determines whether rows in the table can contain a null value for that particular column. And in SQL Server, a null value, as I discussed, is not the same as 0, blank, or a zero-length character, such as an empty string. Example, a null value in the color column for the production. Now, the product table of the AdventureWorks database does not mean that the product has no color. It just means that the color for the product is unknown or has not yet been set or decided upon. Nullability of a column can be defined either when creating a table or modifying the table. The null keyword is used to indicate that null values are allowed in the column, and the not null keyword is used to indicate that you cannot leave that particular column blank or empty. When inserting a row, if no value is given for a nullable column, then SQL Server automatically gives it a null value unless the column has been given a default definition. We'll see this later. It is also possible to explicitly enter a null value into a column regardless of what data type it is or whether it has a default associated with it. Making a column nullable enforces data integrity by ensuring that the column contains data in every row. In the following code snippet, the create table statement uses the null and not null keywords with the column definition. Please highlight this and copy to your script. All done. Now, this is what it is that we're illustrating. You notice we also used this in the previous tables that we created. You can scroll up and see that. I'll highlight it and execute this. Okay, I've copied this command. I'm going to highlight it. Notice the comment is given up here of what it is we want to do. I'll click on the execute command. Then make sure you refresh this. Go to the databases node, go to the database, then tables, give your computer some time, then you can see the store details is created down here with the columns which you have specified. We move on. Now, the result of the code is that the store details table is created with store ID and name columns added to the table. Now, what was this default definition we were talking about? A default definition can be given for a column to assign it as a default value if no value is given at the time of you creating that particular table, or when you're inserting values into that row, or when you're inserting values in a row in that particular column. Example, it is common to specify 0 as the default for numeric columns, or NA or unknown as the default for string columns when no value is specified. A default definition for a column can be created at the time when you're creating the table, or you can use the alter statement to add it at a later stage. When a default definition is added to an existing column in a table, SQL Server applies the new default values only to the newly added rows of data. We have this command. Please highlight it. We are going to create a store product table, and we have the product ID, which is an integer, not null. Name, remember we said in varchar, 40 characters, not null. Price money, not null. And you can see we are setting the default price for whichever product it is that we're going to sell for at 100. We copy this, then switch to the machine. We have this. We are creating a table with a default definition. Highlight the command, execute it. It creates for you. You can refresh. You don't have to go all the way up there. You can still right click on tables, then select refresh, and you can see that the store product table is created, and you can also view the columns of this. The next thing you're supposed to do is to insert this record. Please highlight, then copy and paste into your query window. Now, we want to insert a record into the store product table. We have the command here, and kindly note that this table, if you look at the definition up here, it has 3 columns. But you notice we're only inserting values into the product ID field and the name field. this is going to get filled automatically because we have set the default value as 100. I'll highlight this, execute it, and it tells you one row affected. You can display the records in this particular table by typing in this command. We want to display, select everything, star is for everything. The name of the table is DBO dot, then you select that option, press tab, then highlight and execute this particular command. And you can see that the values which we specified are added, and the default price of 100 is added here. We move on. So this is the output. Now, kindly note the following. The following cannot be created on columns with default definition: a timestamp data type, an identity or row GUID column. GUID is short for globally unique ID, and an existing default column or a default object. Let's look at the identity property. Now, the identity property of SQL Server is used to create an identifier columns. It can be a single column or it can be several of them. And these contain auto-generated sequential values to uniquely identify each row within a table. An identity column is often used for primary keys. Some of you know what a primary key is. For those of you who don't know, just hold on. We will discuss this later. We'll discuss this later. The characteristics of the identity property are given below. Now, a column having the identity property must be defined using one of the following data types: decimal, int, numeric, small int, big int, or tiny int. A column having identity property needs not have a seed and increment value specified. If they are not specified, a default value of 1 will be used for both the seed and the increment. We'll see what these are. Now, a table cannot have more than one column with an identity property, and the identifier column in a table must not allow null values and must not contain a default definition or object. Columns defined with the identity property cannot have their values updated, and the values can be explicitly inserted into the identity column of a table only if the identity insert option is set to on. When this is set to on, the insert statement must, please note that the keyword here is must, they must apply a value. Now, once the identity property has been set, retrieving the value of the identifier column can be done using the identity call keyword with the table name in a select statement. To know if a table has an identity column, the object property function can be used. To retrieve the name of the identity column in a table, we have this other function called column property, and the syntax to add identity property when creating the table is given below. We have this remains the same. The only difference is this column name data type. Then you tell us that it's identity, seed value, then the increment value. Now, what is this thing you are calling seed and increment? Seed is where you want to start from. Like you want to start from 1, you can start from 100, you can start from 1,000. It's basically your preference. Increment value is how you want to go about it. If you're starting at 1, are you going to increase by 1 to get 2? Are you going to increase by 5 to get 6? It's basically your choice. We have this example. Please highlight and copy, then switch to the query window, and we continue. Now, we want to create a table with the identity column. The statement to be issued is a create table HR contact phone. We're going to create the person ID. The type will be integer. It's an identity. The seed is 500. The increment is 1. Meaning the first record we insert here will be 500. Then the next one will be 501, 502, and so on. Then we have the contact mobile number, which is a big int, and this should also be not null. Highlight this, then execute it. You can refresh the tables so that you can see our table is created here. Now, the person ID column is an identity column. The seed value is 500 and the increment value is 1. And while inserting rows to the table, if identity insert is not turned on, then explicit values for the identity column cannot be given. Now, instead, statements similar to the following code can be given. Please highlight and copy this and switch to the query window. We want to add records into the HR contact form using these statements. I've already highlighted. You just click on the execute and it adds 2 rows for you. Now, there is an easier way of doing this. I will show you how to go about it. First of all, we are going to display the records in this table, delete them, then I show you the easier way of adding this. It's going to be your personal choice of how you want to add the records. Now, this is the command we're going to use to display the records from the HR contact table. I'll highlight this, then click on the execute command, and you can see it started at 500, then 501. Then we're going to delete all the details in that table. We talked about this command earlier. I'll highlight this, click on execute. Sorry, it's HR contact phone. I'll highlight this, then execute. Okay, then confirm whether all records have been deleted. So it's currently empty. Now, if you check, this is the code that we use, and it actually has the same effect like what you had up here. Let me minimize the results window. You remember how we talked about doing this in the previous session. I'll highlight this, then click on execute. 2 rows affected. Then display the details. Execute this, and you can see we basically have the same details. Now, what are the advantages and disadvantages of each? This is better for one reason. In case this fails, then the query does not halt. It can move on to the next one. This is easier to type, but in case of an error in one of the values, then the entire query is actually going to abort. So please make a wise decision on which one to use. Save your work. We move on very quickly. Now, GUID, that is the globally unique identifier. In addition to the identity property, SQL Server also supports globally unique identifiers. Only one identifier column and one globally unique identifier column can be created for each table. To create and work with globally unique identifiers, a column of row GUID call, unique identifier data type, and new ID function are used. You're going to see this. Values for globally unique column are not automatically generated. And to do this, one has to create a default definition with the new ID function for a unique identifier column to generate a globally unique value. This function, that is the new ID function, creates a unique identifier, which is a 16-byte binary string, and the column can be referenced in a select list by using the row GUID column keyword. To know whether a table has a row GUID column, we use the object property function, and the column property function is used to retrieve the name of the row GUID column. The following code snippet demonstrates how the create table statement is used to create the employee or emp cellular phone table. The person ID column automatically generates a GUID for each new row added to the table. Please highlight this and copy, then switch over to the query window. Make sure you add this comment. We highlight this, then execute it. Confirm. Right click, refresh. The table is added here. The next thing you're supposed to do here is to add values into this table by copying and pasting this command. Please do that very quickly. We have this statement to add the record for William Smith in the employee cellular phone table. Highlight it. Then you can click on the execute button. You can display the records in this particular table by using the select start statement. Display. Okay, highlight and execute, and you can see the details are displayed here. What you're going to notice is that your results will actually be different from mine. This depends on the machine that you're doing this. I'll actually switch over to the laptop so that you can see this. So I'll highlight these three commands, starting from here all the way up to here. I'll copy, then do this in the laptop. Now, I'm going to execute them as a batch. Click on execute and notice that the results are different. This is, so you notice this is what you have in your slides, and this is what I have in the campus machine. This is what I have on my laptop. So this is guaranteed to be globally unique. We move on. Constraints. A constraint is a property assigned to a column or set of columns in a table to prevent certain types of inconsistent data values from being entered. And constraints are used to apply business logic rules and to enforce data integrity. Constraints can be created when a table is created or added at a later stage using the alter table statement. Constraints can be categorized either as column constraints or table constraints. Column constraints is specified as part of the column definition and applies only to that specific or that particular column. And table constraints can apply to more than one column in a table and is declared independently from column definition. Table constraints must be used when more than one column is included in a constraint. Now, SQL Server supports the following types of constraints. We have the primary key, abbreviated as PK, unique foreign key or FK. We have the check, and of course, not null is one of the constraints. Now, let's look at the primary key. Now, a table typically has a primary key comprising a single column or combination of columns that uniquely identify each row or tuple within that table. The primary key constraint is used to create a primary key and enforce integrity of the entity in the table, and only one primary key constraint can be created per table. Two rows in a table cannot have the same primary key value, and a column that is a primary key cannot be left empty or cannot have null values. The syntax to add a primary key while creating a table is given below. We have create table, then the name of the column, then we use the primary key. We have this example here. Please highlight it, copy, and switch to the query window. Now, we highlight, then we execute, confirm that this has been created by refreshing this. Our emp contact is created here. Then we want to insert records into this table to confirm this. Now, we want to insert these records, and beforehand, as you can see, this query is not going to work. We are actually going to get this particular error. Please highlight this, copy, and then switch to the query window. Now pasted, I'll highlight, then execute, and kindly note that I'm using the short version. You can see that we get this particular error. Cannot insert duplicate key in object DB. Cannot insert duplicate key in object DBO emp contact phone. The duplicate key is 101. This is what we are doing wrong. Now, if you want to check what has been inserted, you can right click on this table. I'll refresh first. Tables, then refresh. Then you remember the shortcut. And you can see what I told you earlier. We said that if you do it this way, and one has an error, it means the whole query is going to abort. But if we had the other version, please try that and see what actually happens. This is going to give you the results as displayed in the query window. So make sure you make a wise decision when inserting records into tables. We move on. Unique. A unique constraint is used to ensure that only unique values are entered in a column or set of columns. Unique constraints allow null values. A single table can have more than one unique constraint, and the syntax to create unique constraints is as follows. Create table, the name of the table, the column list, then column name, the data type, then you give us the unique constraint on the specific column. We have an example here, and it demonstrates how to make the mobile number and landline number columns as unique. I'm quite sure each of you has a unique phone number. Please copy this, then switch to the query window. I've pasted, and just to point something to your attention, if you look at line 109, I've added the primary key. Now this is called the primary key function, and you can see I'm passing in the value of the person ID field. This is the other way that you can specify the primary key. Feel free to choose which you like. We highlight, then we execute, and the command completes successfully. We refresh the tables, and the table is created. emp_contact phone is created here. Then we go back and try to insert duplicate phone numbers. Highlight these values. Please notice that these two are the same, then try to insert, and this is what you're going to get. Now I'll type in exactly the way this is, and you'll see that we get a result of 1, rather as to what we got in the other one, where we didn't get anything once we tried to check for results. Now we want to add the records. I'll hide the results window. Highlight, then execute, and you can see what happens here. Violation of unique key constraint. Cannot insert duplicate key in object DBO emp, and it gives you the duplicate value, and it tells you that the statement has been terminated. We want to find out how many records were inserted. Let's do a select star very quickly. Shift home to highlight all the way to the beginning. Then you click on execute, and you can see now this one gives you at least one record. Okay, it's up to you to make a choice. We move on. Foreign key. Now, foreign key in a table is a column that points to a primary key column in another table, and the foreign key constraints are used to enforce referential integrity. The syntax for foreign key is given below. Create table, the name of the table, you give us the column list. Then we have the foreign key references. You specify the table which the foreign key is referencing. You tell us which primary key it refers to, and then the column list. We have an example given here. Create table. We have an example given down here. Highlight, then we switch to the query window. Highlight this command. Tap on F5 to execute it. Then we want to insert data that is not present in this table that we created previously. That is the emp contact phone. So we are going to be in violation of this, and it's not going to allow us. We are going to see the error. We're going to see that error that is in your slide. So please highlight this and switch to the query window. Now, we want to try and add the details of an non-existent mobile number. I'll highlight, then execute this. And you can see the error message which we are getting. We move on. Check. Now, the check constraint limits the values that can be placed in a column, and the check constraints enforce integrity of data. A check constraint operates by specifying a search condition which can evaluate to true, false, or even unknown, and values that are evaluated to false are rejected, Multiple check constraints can be specified for a single column. A single check constraint can also be applied to multiple columns by creating it at table level. The following code snippet demonstrates a check constraints to ensure that the amount value will always be non-zero. Now, if you look at this query is not going to work because we've already created this table. We are going to have a collision. What we are going to do is to use an alter statement such that we ensure that the amount is always greater than 10. I would like you to challenge yourself by doing that. Write an alter statement that will ensure that the amount is greater than 0. Then we continue. Okay, here is the statement. Alter table DBO emp phone expenses. Add check amount greater than 0. I've already highlighted it. I'll click on execute. Then we try to enter a negative amount in the amount column. Try to do this and also ensure that the phone number you're trying to enter exists in the employee phone contact table. Okay, I'll try to enter a value of -40 and this is not going to work. Execute. And you can see the statement is not working because this check constraint is being violated. Okay, we switch back. Now, not null constraint enforces that the column will accept not null. Now, as we have seen earlier, this constraint basically ensures that the column is not going to be left blank or accept empty values. And the not null constraint is used to enforce domain integrity, similar to check constraints. And with that, we've come to the end of the session. Let's summarize very quickly. Now, a data type is an attribute that specifies the storage capacity of an object and the type of data that it can hold, such as numeric data, character data, monetary data, and so on. SQL Server supports 3 kinds of data types. We have system data types, alias, and user-defined data types. Most tables have a primary key made up of 1 or more columns of the table that identifies records uniquely. The nullability feature of a column determines whether rows in the table can contain a null value for that column. A default definition for a column can be created at the time of table creation or added at a later stage to an existing table. The identity property of SQL Server is used to create identifier columns that can contain auto-generated sequential values to uniquely identify each row within a table, and constraints are used to apply business logic rules and enforce data integrity. A unique constraint is used to ensure that only unique values are entered in a column or set of columns. A foreign key in a table is a column that points to a primary key column in another table. A check constraint limits the values that can be placed in a column. We've come to the end of the session. Have a nice time and God bless. Bye.